Do you know what the coolest thing is? Well, at least in my opinion, the coolest thing is the entire universe. I think it's just absolutely amazing. Absolutely amazing. And I want to know everything that I possibly can about it. And it, uh, it drives me a little crazy, right? When you don't quite understand things and realize that you're probably totally wrong about that. Whatever you're thinking, it's like, well, yeah, that's probably not right. But yeah, I think that is the coolest thing is all of this, all of this. And so, oh man, I do not have any. I don't have any fuel. I don't have any fuel. All right, I'm probably gonna have to take a quick break to figure that out. So I hope that this live stream is going okay. I'm watching it with my smartphone, and everything looks okay. Um, yeah, my apologies for what it's worth in terms of yesterday's stream. I got home from work and found out that things were running really slow, and it's like, well, let's just monitor this, and yeah, it actually continued to be slow. Um, what? Yeah, I don't know. I finally realized that it's like, oh yeah, I should probably just cycle power on the modem, right? We've got DSL. Um, oh, that's very cool, Atta. So tell me what you saw. List some things that you observed. Like to hear that. Yeah, it's I think doing scientific research with curiosity and awe. I think that's um, I think I can honestly say that every scientist that I've ever met has had that, whether they know it or not. And a lot of them just don't see it that way. That uh, they're having such a great time um, that they don't realize how much in just amazement they are. So, but yeah, I can honestly say that those elements are always there. Um, but then there's skepticism and open-mindedness. So you have to have all these elements in order to do that thing that we call science. Yeah. Okay. So you looked at Moon and Mars, and Mars just looked like a brighter red star, right? So yeah, you probably um, very certain you probably didn't see any kind of detail. Um, it just looked brighter, right? And that's because of the size of the binoculars. What did you end up getting, or did you have some? Don't remember exactly. Were they 10 by 50s, like what we were talking about, or um, okay, yeah. My thing, right? I mean, if I'm going to encourage anything at all, is that you need to start uh, at the beginning. You need to start with the basics. That's why, um, uh, I encourage everyone. to read those scientific papers over on archive.org. And if everything is just flying over your head, right, out of reach, just it's over your head uh, and out of reach, right? It's like it's impossible, right? So what I do in that case, which I mean, most of these papers are like that for everyone, right? Some more than others, but I mean, most of the papers are above the reach of most astronomers, most of them. There's a few that are going to understand all of it. There are many that will understand some of it, and that's probably where I lie. And then there are going to be also many who just don't get it at all. So I'm somewhere in between those two. I might get a couple of things, but yeah, for the most part, most of those papers are like completely out of reach. And so what I do in that case is uh, I pick uh, I pick one. Oh, I just read in the chat that right. So you got 10 by 50s, which is great. That's you will be really happy with those. Really happy with those. Stellarium is absolutely fantastic. Yeah, I've got that running over here that way on my Linux machine, and yeah, it's absolutely great. Uncle Bill is in the chat, and he knows quite a bit about Stellarium as well. So um, Uncle Bill is a uh, pretty much an expert on that too. So yeah, I picked it up maybe a year ago or so, maybe a little bit more. I don't know. I lose track of time. I don't pay any attention. Um, yeah, a year ago, maybe two, and yeah, it's pretty nice. It's pretty nice. So you'll like it. It's a little bit of a learning curve, and it's much more powerful than um, uh, than the little bit of stuff I do. It its capabilities are quite amazing. Um, yeah. Yeah, just Ata, as I said, just be patient and expect to be frustrated with yourself, right? Because it's like, why can't I get this? And but you got to be persistent, and you got to be a little bit stubborn, but you also have to try to be very forgiving of your own process, because I mean, what's happening, right, is that this knowledge is being etched into your brain, right? So once you get some of these ideas, concepts, views, whatever it is, right? Once you get it, it is going to be so burned into your brain that you will never forget it ever. So that's what you're experiencing, is that etching process, right, or that carving process. Um, and yeah, that's that can be a painful experience. But yeah, just take your time, make sure you're having fun most of the time, and that's all. And be patient, go at your own pace, right? I mean, if uh, you may find that all of this is extremely easy, right? I mean, that's what I found, right? It was it was extremely easy for me to pick up on all the knowledge I could ingest. Right, it was really, really, really easy. Um, so you may find exactly the same thing, or some aspects are easier than others. Hey, with those binoculars, if you can, if you can, it would be really, really great if you could set it up on like a tripod. You On most binoculars they have like a quarter 20. Um, uh, I guess you'd call that like a female thread, um, uh, into which on many um, tripods there's a male quarter 20. See if you can attach that up and still be able to look through the binoculars, because you will have a much better um, a much better uh, uh, observing session if you're not having to hold it, right? Because no matter how steady you are, right, these binoculars are magnifying your motion, right? So unless you can be 10 times steadier than what you currently are right now, then you're always going to, be doing this, right? And I mean, I'm exaggerating, but it's like, you know, so see if you can get your binoculars set up on a tripod of some sort, or some kind of mount, right, that you can put on the ground so it doesn't move. And then uh, you set it all up in terms of focus and all of that. But otherwise, it's like hands off, right? And you just look through them. Yeah, I don't have any suggestions in terms of uh, sky apps. I'm I've seen a few of them, and uh, I didn't uh, I didn't really see any kind of significant difference between them in terms of what they do. You hold the phone up, and it shows you where things are in the sky, and that's very cool. That's very, very cool. I'm so if you want to go that route, I think that'll work. That'll work great. That'll work great. And my thought is that one is about as good as the other. So look at the reviews, look at the score they get, look at how many times it's been downloaded, um, and you know make your choice based on a little bit of instinct. Yeah. So yeah, I as I said, I'm an old school dude, and so my go-to, right? My go-to is that, where, and yeah, this is old school, whatever. But hello there, Gilles. But these are actual physical charts, right? They're pieces of pieces of paper here, right? Pieces of paper. Can you see that? So, and they each fold out to this big to this big chart that I can. What I do is I just lay it on the hood of my vehicle, and I've got the telescope right next door, so I can just zip in zip in between them if I have to, or I can bring these charts on the ground and have them right there, whatever else. But so I'm just an old fashioned dude, and I like the objects. I like the objects. But those apps those apps are are great as far as I can tell. I don't think that you're going to go wrong with really any of them at all. So yeah, as I said, look at the reviews. Um, I don't know if you have to buy those or if they're free, but sometimes you get what you pay for. Sometimes. Is this out of focus? I think it was a little bit out of focus. That looks a little bit better. Let's see. I'm just reading the. Oh, Gilles is reorganizing his office. Oh my God. Well, I will have to. Your shows usually run while I'm at work, and so it's very very rare that I'm going to be sitting at a computer. Uh, um, uh, uh, and being able to watch and or listen. Um, just usually doesn't happen. So I always try to catch Jules's shows live streams after the fact. Sometimes I pop on at work for a short amount of time, but then I get pulled away, and it's like, oh well, oh well. And Totterbird is on. Nice to see you in the chat. Singing for sure tomorrow night. Yeah, Uncle Bill, I totally agree. I never liked the planispheres. I mean, I could understand them too, but they were a little bit more confusing to me. I really, really like these flat charts that are. I mean, that is what it actually looks like in the sky. So the geometry's right. I guess it's not exactly perfectly right, but it's really, really close. Um, and yeah, I had an affinity for those, and so of course those are the ones that I am going to recommend the most, or the ones that I like the most. Uh, but yeah, I think those apps are definitely pretty intuitive, and you sort of it. Uh, those apps have been written such that when you hold the camera out, the scale is the same, right? So what you see, I think, what you see on the screen is what you sort of see in the sky, right? At least to a certain radius. So I think that's great. I think that's great. I think that is probably extremely helpful because, as I said, what was it, a couple nights ago, um, one of the hard things is to go from those charts to the sky. It's that translation, right? Because and you've got to translate in multiple ways, right? Uh, you have to do a translation in of brightness, right? Because on that chart, right, a bright star is just big. It's a big black dot, and a faint star is a small black dot. And in the sky, they don't look like big dots and little dots. They look like bright dots and dim dots. So you have to be able to do that location translation. I was I was reading the chat. Um, so you have to do that translation. Then you have to do the translation where it's like, okay, I'm going to look at these three stars. Okay, that one, I'm looking at the chart, right? That one, and that one, and that one. I I tend to use and see triangles. So I'll usually find a triangle, right? And it's like, okay, that one, and that one. And then I look up, okay, where I think that's supposed to be, and I look for that triangle. Now that it could be rotated, right? It doesn't have to look like what it does on the chart, right? It has to look, yeah, I mean, depending on where it is in the sky, right, it's going to be rotated around. So you have to take that into account. You also have to figure out, it's like, what are the distances? Okay, this far on the chart is how far in the sky. So you have to do all of that, and but once you do those two transformations, and hopefully it's easy for you. As I said, for me, it was extremely easy. I mean, I had, it required no effort at all on my part. Um, let's see, catching up with the chat. Talking about the weather. Yeah, well, it's summertime. It even gets warm up in Canada. I can't believe it. We're up. I'm up pretty high here. I'm at about 40. I think about 4,500 feet or so. So we don't get nearly as hot as Tucson or Phoenix. Um, Phoenix this time of year, right, will be up in the 150, one teens, 120s. Tucson will be, you know, 105 to 115. We'll be at that point like in the mid to high 90s or so. We're about maybe 10 degrees cooler than Tucson usually. But having said that, I think it was a couple days ago, we hit 106 Fahrenheit. So I love it. I think it's great. That's one of the many reasons why I'm here. And actually, when I lived in Tucson, um, which was hotter, right, much hotter, I liked it even more. It was just great. It's like, come on, let's just go bake, right? Let's just go bake in the sun, crackle, 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 and all of that. Yeah. Um, so I like the heat. I have no problem with the heat. But today officially marks the beginning of our monsoon. We're I don't think that we've been hit here yet, but I have seen a couple of sprinkles, and just to my south and west, it is currently raining. So I wouldn't be surprised if we get some rain later tonight. We'll see. We'll see. Um, Bobby, I was going to talk about that. I'm having a problem deciding, right? So I mean, I've got to be cheap because I'm just a poor independent research astronomer, right? Just scraping by, and having a ball. Um, but so spending $30 on something like this um, is uh, I mean, it really isn't a huge deal, but that, relatively speaking, is a pretty big chunk. It's a pretty big chunk. So but yeah, that isn't the problem. I came across a little bit of extra cash, and so that's where it logically had to go. But I'm trying to decide between the there are two Logitech cameras that I can't tell what the difference is. There's the Logitech, I think it's called the C270, and then there's a C615, and those are the two candidates that I have right now, and I'm trying to figure out what the difference is between them. Haven't been able to figure that out yet. But if anybody has any other suggestions, right? I'm looking to spend like 20 to 30 bucks, right? So I mean, I can't really go over 30 for sure. Oh no, I I messed up my cord again. Oh, I can't believe I did that. Okay, I'm gonna put you down. Hold on. All right. Phew. That that's a relief. Yeah, yeah. It's well, it depends, I guess, on what you consider to be hell. So when I landed in Tucson in the summer of 1987, they were on day, I believe, 40 of over 100 degrees in a row over 40 days. I think that went another 20 some days until the monsoons hit, and then that was the end of that. Um, you think that the 270 can only do 480? I I don't know. I was looking. I guess I didn't look at. Yeah, I guess I need to look at the details. Go for the C15. Okay. All right. All right. I will do the C15. Okay. I'm glad I remembered those numbers because yeah, sometimes those things don't stick in my head. All right. I'm gonna look at the C 615 and look a little harder at it, and then probably get that in the next 36 hours. So I'm also going to get one of those. What are they called? Um, let's go on a little adventure because I want to get this right. Yeah, 720 is probably about as good as my bandwidth is going to handle because I think that's what I'm transmitting now is 720. So I'm just hoping that this camera will be a little uh, better. So what I'm looking for is this. It's this focusing device that allows you to focus when you're using a CCD camera. And oh man, I'm telling you, what you're about to witness is the power of Google. Okay, because look, the only thing that I have in my head right now is a picture of it. I know what it basically looks like, but I have absolutely no words for it at all. So let's see how well Google is as a tool to find the words that I am looking for. And I don't even remember how many words there are. I think there's two, but let's see. So I'm going to do Celestron, CCD, focus. There it is. That's amazing. That is amazing. It's a Bahtinov focus mask. And so now what we're going to do is we're going to go up here and we're going to so I'll show you what these look like. That's pretty impressive. Google. Got to get the right, you got to think a little bit of the right words, but yeah, I totally agree, Uncle Bill. I think that's as much as my poor little thing will handle. So this is taking a little while. I hope I'm still streaming here. Am I still streaming? I can't tell if I am or not. Oh, this is taking an unusually long period of time. It looks like my cursor is moving. I'm watching my my live stream on the smartphone, and it does seem to be moderately live. So sorry about all of that. That's how it goes. Yeah, it's trying. It's trying to move around. I don't know why it's taking as long as it is. Let me reload it here. See if we can get a little bit better satisfaction on a different channel. It's waiting for cloudy nights, huh? Well, there's probably other places because this seems to be working okay. Just want you to see one. There's an eBay one. Bahtinov mask. So what this does is it projects a pattern onto your CCD camera that will change depending on the how in or out of focus you are, and a certain pattern, and I forget exactly what it is, but it's easy enough to find out. A certain pattern will be seen if the system is in focus. So that's what I'm waiting for here. Oh, currently sold out. I'm not getting, oh, here come the pictures. That's a filter. Yeah, I think, Bobby, it's just me. It's just my internet is still having troubles. Now it's got all the pictures except for the one that I want you to see. So that one hasn't loaded yet. It's going to load that one last. Got to load all of those. Yeah, I've got certain sites. I don't know. Certain sites are not looking good. Well, I wanted to show you that. Anyway, that's what I'm going to. That's the other item that I'm going to. That I'm going to get with this little extra pile, just with nothing to do. So I'm going to send it on its way and exchange it for a couple of things. And yeah, the I think although I don't quite understand yet, but I'm thinking that focus has a lot to do with sort of the inconsistency that I'm seeing with the data that I'm collecting with this scope. And I can't quite, yeah, it is. It's choking and chalking. Speaking of choking, I'm going to take a quick break, fill my mug. It's hydrogen hydroxide tonight. Again, I can't go crazy, right? I need something nice and calm. So so let me do that, and then we'll come back and completely change the subject. All right. All right. Much better. Cheers. All right. I think that, and yeah, the delay is really huge too. Wow, it's really huge. It's like I'm seeing at least like a 20-second delay here. Amazing. Amazing. Thanks for the link, Uncle Bill. Oh, by the way, down in the description, there is a new link to my Discord server. It is the permanent link. I finally, Uncle Bill, I finally figured out how to do that. How many weeks has it taken? I only tried once though, and that was yesterday. and so once I got it, I changed it down in the description here too. So the one in the description should be a permanent invite. So yeah, it's not going to expire or anything like that. So, but I'm pretty sure that that is also the link that Uncle Bill just put into the chat. Into the chat. All right, so there are 88 constellations in the entire sky. And I think it was Tom, who I don't think is here, at least not in the chat. I think it was Tom who mentioned that there were 36 in the north and the rest were in the south. And I'm going to grab my still working. Have I used it today? I want to say that I did, but I'm going to push all eights. I was that fourth digit that was having a problem. And look, it's there. uh, so, yeah, still, I'm still one of those good scientists. So there's 88 and there's 36 in the north, which means that there are 52 in the south. So what, 36, I'll do this up here, 36 divided by 52. So you have a, let me do it this way, plus 1. You have a 30, or we here now have a 30.769% chance that it's going to be a northern hemisphere constellation, and a whatever that is, 69.3% chance of a southern constellation. So a pretty good chance that our constellation of the day will be something in the south, something that us northerners cannot see or will rarely see depending on the season. But let's do that anyway. So what I've got over on my Linux machine here, I'm going to pull it up. I have, let's see, it's in that, and then it's called const. So I have an alphabetical list of the constellations up on my screen. So now let's go over to random.org. If I can pull it up, let's see. Maybe this thing came up after all. No, it didn't. It just petered out. Okay, well let's try going over to random.org and hopefully we'll be able to get over there. Okay. It looks like we are getting over there. Wow, it's really slow. Yeah, I'm gonna have to do some investigating a little bit here because that's not an acceptable speed. Okay, well, it did load. So let's go 1 to 88. Come on. So it's going to choose a random number between 1 and 88. And then I will go to that constellation on the list, on the alphabetical list. And that's, we'll just explore that constellation a little bit. All right, ready? Ready? Okay, drum roll. 16. Okay, so I'm going to go to my list, and I'm going to go down to number 16. Capricornus. Capricornus. Well, that is definitely a northern hemisphere constellation, I would say. Capricornus constellation. Wikipedia usually has what I sort of consider to be the best presentation. So here it is in the sky. Zoom in a little bit here. Oh, so that's it. That's all we get. So it's not a huge constellation. It's not a small one either. But it's, yeah, I guess it's sort of medium sized for sure. For sure. So it looks like there's a Messier object in here, M30. It's a globular cluster. And then, as I've said before, the visible stars usually have like Greek letters. And usually the brightest star in the constellation is Alpha, and then the next one is Beta, and the next one Alpha, Beta, Gamma, Delta. It, just goes on from there. But I don't know if some of that fell apart over time, or if things changed, or what. But Capricornus is a really good example of that system that I just described to you as being completely wrong, because as you can see, this star, or maybe this star, is the brightest one. What they're calling alpha is not the brightest one. And actually, there's an alpha 1 and an alpha 2. That just means that they're at least two stars that are just uh, they at least appear to be next to one another. Now, they don't physically have to be; they just have to be in the same line of sight, right? One can be closer to us than the other one. The other one can be behind the foreground one, but they can still appear, from our line of sight, to be next to one another. And this is probably one of those cases where it just so happens that a couple of stars, almost align, and so they sort of look like a binary star. And so they've got alpha 1 and alpha 2, but that's not the brightest star in the constellation, right? So that falls apart. And then there's Omega down here. Isn't that Omega? So Omega is the last letter. I mean, I guess I would have to. I guess I'd have to go through it, but I don't think that all the letters of the Greek alphabet are represented there. I don't know. Maybe they are. Maybe they are. But it's a little strange to see an omega. Anyway, this is pretty easy to see in the sky, because it sort of makes this. I mean, here it is again. It's sort of like a triangle, or almost like a chevron, right? Like a funny looking Star Trek chevron. And yeah, Capricornus is a zodiac constellation. And the way that you know this from this diagram that we're looking at is, you see this blue line here? That's called the ecliptic. And the ecliptic is a couple of things at the same time. It's, number one, it's the path that the sun apparently takes against the background sky as the Earth orbits the sun, right? As the Earth orbits the sun, where the sun is in relation to the background sky changes. And so it appears to move in this circular pattern against the background stars. And number two, what it is, you can sort of, if you take the sun and this line, that defines a plane, right? A plane. And that plane is the plane of the solar system. So that's the sort of the disk that all of the planets, at least all of the planets, most of the asteroids, not so much the comets, definitely planets, asteroids, minor planets, whatever, basically move along this ecliptic. You will find every single planet and asteroid, for the most part, will always be very, very, very near this blue line, the ecliptic. And what defines it as a zodiacal constellation is the fact that the sun goes through the constellation, right? So when the sun is in this constellation, it's said, right, that if you're born between the date that the sun enters the constellation, which would be over here, to when the sun exits the constellation. If you're born between those two dates, then you are a Capricorn. Yeah, I don't remember what those dates are. Um, hmm. Well, if anybody knows, oh, it's got to be like January or February, something like that. Maybe into March, maybe something like that. Um, but anyway, there's quite a few bright stars. But as I said, it's actually pretty easy to see in the sky because there's a lot of stars to sort of trace out this this chevron shape, almost like a weird looking triangle. Looks like there's a few other. Oh, excuse me. It looks like there's a few other globular clusters in the area. That means that we're probably near the galactic center. The globulars tend to hover around the center of the galaxy. It's part of what's called the galactic halo, are these globular clusters out there. Every globular cluster has about 100,000 stars in it. So they're like mini galaxies. Some people think that there are black holes in them and all that, but nothing's been seen yet. Nothing's been seen. You know, models say one thing and nature sometimes says something else. So, the jury is out on these. They're very mysterious objects. We're really, uh, they're pretty strange. Yeah, they're pretty strange. But you know what? What isn't? Right? All this stuff is pretty strange stuff. But that's what makes it extremely interesting, right? Because it's like, what is going on? So let's see. You know what I like to do is I like to jump over to Burnham's, but before I do that, let's just look at the size of this thing. It's not really all that big, right? It goes from about 20 hours right ascension all the way over to 22 hours. So this is 30 degrees, right? Every hour of right ascension is about 15 degrees or so. Um, so this is about 30 degrees. And then look, we're going from a declination of about -10 down to about -30. So that's 20 actual degrees. So it's 20 by 30 degrees. That's um, that's 600, 6,000. Is that right? 6,000? No. 600, yeah? 20 times 30? Can't do that in my head. Yeah, 600. So that's 600 square degrees. So yeah, as I said, I think that's a pretty average size constellation. Pretty easy to figure out. Pretty easy. You need I don't think you can see this in the city, but get out a little bit where it's dark, and uh, you'll see all of those. So Bobby asks, okay, well, I think I sort of answered that. How does the Earth's axis affect the number of constellations? Well, the number of constellations is defined by the currently defined by the International Astronomical Union, the IAU. They define what constellations are and which ones aren't. If you're talking about how if the Earth's axis affects the number of constellations in the zodiac, yes, it would, because this ecliptic, when it intersects the celestial equator, which is up here, right, it's going to intersect it more to the left off the chart here. But when it intersects that, it is going to make that intersection at an angle of about 23.5 degrees, which is exactly the tilt of the Earth. So if the Earth was tilted differently, then the ecliptic would be would still be a line, but it would pass through different parts of the sky, and we would have we could have a completely different set of constellations depending on where the ecliptic is, which is defined by the axis tilt of the Earth. So whichever way you meant to ask that, Bobby, you got them both. All right, now what was I going to do? Oh yeah, I was going to, we're going to take a look at Burnham's. You know, this again, this is old school, I guess. It's you know, I I definitely do not claim that my ways of doing things are even a good way to do them. It's just this is what I enjoy, and this is what I find, I guess, easy, right? And when I find easy ways of doing things, I usually do them. So anyway, so Burnham's isn't. I don't think it's published anymore. I think we looked that up somewhere, and I don't think it's published anymore. You can usually find them in used bookstores, though. So, but it's a 3-volume set, right? It's 3 volumes, and it's an alphabetized list of the constellations. And so I'm going to go to Capricornus, which is in volume 1. Now, volume 1, I have had these books. I've had these books for about 35 years. About 35 years. This one still has a cover and a thing on the side and a back. It's the whole thing. I've still got it. See, this is this is volume 3, and something spilled on this thing, which is bad enough, right? So something spilled on this, but there's no front cover, there's no front page, right? There's no back thing, and there's no back to it at all. It's just a big lump of paper with some glue, some glue holding it on. So, but that's what happens. That's what happens to things when they are used for 35 years. So I'm going to go to Capricornus. I think I am. N. I'm a little confused. It's not, there it is. Wow, it's a lot shorter than what I thought it was going to be. Wow, that's almost disappointing. All right, well, wow, it's really short. So Burnham's lists the all the binary stars. So that's all the binary stars, at least as of this date. There are probably more there now. Yeah, so there's alpha. So there's an alpha 2, and an alpha 1, and each one of those is a binary star. So it's a pretty complicated setup there. Pi, rho, zeta, tau, tau Capricornus. So then here's all the variable stars and the deep sky objects. There's only two deep sky objects down there. There's a galaxy and a globular cluster. That globular cluster, of course, is M30. It's also M30 is also known as NGC 7099. So then what it does is Burnham's goes through some of the brighter stars and presents pieces of information, I guess whatever they know. But for most of these constellations, there are pages on each one of these stars. Okay, this is like 2 paragraphs. So I don't know what's going on with Burnham's here. So the 2 bright stars do not form a true physical pair. Okay, so that's exactly what I was just saying before. Alpha 2 is about 100 light years distant. It shows an annual proper motion of about 6 or 0.06 arc seconds and a radial velocity of about 0. The other star appears to be about 5 times as distant. So yeah, so alpha 1 and alpha 2 are not a physical pair. One's here and one's just in the line of sight, but way, like 500 light years away, as opposed to 100 light years away. So beta Capricorni is a spectroscopic triple, which means the stars are so close they can't see them, but they can see that there are 3 different spectra. So that's pretty cool. Delta Capricorni. Oh, well, this is kind of cool. So about 4 degrees northeast of Delta Cap is the spot where the planet Neptune was first detected by J. Gallet at the Berlin Observatory, September 25th, 1846. The results of predictions. So it was in the constellation of Capricorn that Neptune was first discovered, was first seen. That's pretty cool. And then there's M30, which is a globular star cluster. It's a nice one. It's actually one that's overlooked. Yeah. Spring equinox has moved almost a full degree. Yeah, no, I totally agree. You know, and you bring up a motion that I don't really say much about, but that is precession, right? Precession. You know, the Earth is spinning on its axis, right? And at the end of every show, you know, I say the same thing. It's right. You know, hold on to your hats because we're spinning fast, right? We're spinning roughly like 1,000 kilometers per hour, right? Usually less than that, but not, you know, that's a good approximation. Um, but, you know, we also know that at least relative to this ecliptic, right, the plane of our solar system, which is the extension of the equator of the sun, right? Just take the equator of the sun and extend that out in a plane. That is the plane of the solar system, and it's also the ecliptic. Um, so um, man, what was I saying now? Oh, that's bad. I started thinking about I started thinking about M30 again, and I totally lost my train of thought. Oh yeah, precession. So, you know, not only are we spinning like that on our axis, but you know, we're tilted like this. So the whole planet is doing. Do I have? I don't really have anything to do this with, right? It's precessing. It's going around like like that. Also, right, coming towards you, going away, right? So, and it does that like once every 26,000 years. So, you know, yeah, I mean, a lifetime, uh, that thing will have moved, you know, more than a degree, right? Let's see, it's if it's 26,000 years, 26,000 divided by 360. Whoops, I did that wrong. 26,000 divided by 360. So yeah, it moves one degree in 72.2 years. So in a lifetime, right? In a lifetime, uh, that will have moved 1 degree. That's pretty amazing. Yep, wobble, wobble, wobble. All right, so that's all that Burnham's has to say about that, and I have to say I'm a little disappointed. So let's go back to Wikipedia and see if it has anything else. Because what I like to do is I like to pick out something. Um, Share my screen, and we'll go back over to Wikipedia. Well, I don't know why I did that. Well, went too far that time. Yeah, it just so happens that there's a bright star near our our North Pole. You know, there is no bright star in the south because you wouldn't expect there to be one. But I do hear that Vega also gets pretty close to the North Pole. All right, what's going on here? Man, it took me way back. So its name is Latin for horned goat, or goat horn, or having horns like a goat's. So yeah, they're calling that uh, a goat, right? A horn goat or a horn. All right. Notable features. So Capricornus is a faint constellation. I suppose so. As I said, you're not going to be able to see this well in the city, but you know, you get out in a little bit of dark, and you'll see it. So the brightest star is magnitude 2.9. So yeah, that's pretty faint. So the primary alpha 2, they're calling it, 109 light years from Earth, yellow-hued giant star of magnitude 3.6. The secondary alpha 1 is 690 light years from Earth. Okay, so Burnham's wasn't too far off, and it's a yellow-hued supergiant star. The two stars are distinguishable by the naked eye. Oh, okay. And both are themselves multiple stars. Yeah, very cool. There's a nice shot of M30. That's an HST image. One galaxy group is HCG 87. Group of at least 3 galaxies located 400 million light years from Earth. Wow, I wonder if Hubble has ever looked at that. HCG 87. I doubt it. But let's take a look. I know I'm running a little bit over. That happens. Oh, I didn't mean to go here. Come on. So let's do all the imagers, all the spectrographs, and everything else. And what was it called? HCG 87? It's not a chance. Not a chance. Wow. Really? Wow, just looked at back in 1999. Huh. We've picked 2 different wavelengths. Wow. Hey, I think we should grab some of these. What do you say? Can we just grab some of these? HCG 87001. Okay, so that's that one. That's at 814. So let's go to 675 and hope that it's the same field of view. Oh, yeah. Oh, this is going to look great. You will love it. Two. Okay. So the next one is 450. It's the same proposal. So I'm assuming it's going to be the same. Yeah. See, we're getting bluer and bluer and bluer, more towards the ultraviolet. Oh, this is going to be cool. So that's 3. There's a 539. There's a 539. Let's do it. 5439, that is. Same field of view. Yeah. So we got 4 colors here. Look at that one. Holy moly. I'm excited. So we got 4 of them. Okay, well let's do this fast. Sorry, but you know, it's got to be done. I think this is going to be pretty interesting though. That's a spectacular image. Don't you think? Wonder what these guys were doing. Let's look at the proposal ID while this is while GIMP is starting out. We're observing HCG 87 as part of the Hubble Heritage Project. The aim of the Heritage Project is to provide spectacular HST color images for public release, outreach, and education. So they're just taking cool pictures. Well, they certainly did that. Oh, where is it? There it is. Yeah, I'm anxious to see this with some color. Nice elliptical galaxy here, it looks like. Spiral, maybe in the background. Here's an edge-on spiral, I guess. Something interesting going on there. And then here's another spiral, sort of, you know, not face on, but not edge on, sort of at an angle. All right, boys and girls, here we go. I'm going to put you down just for a sec. Okay, loading. Cheers. All right, they're all loaded. I'm going to turn this to an RGB image. And then I'm going to invert all of them. You won't see any more here because I've got the top layer visible, but they are all going to be inverted. Inverted. Okay, so then I'm going to go back up here and I'm going to change this to screen and this one to screen. It's going to be pretty bright. And whoop. And this one to screen. And this one to screen. Okay. So let's turn off this one. Let's just use these first 3. Now, I don't remember, these are in order 1, 2, 3, 4. So let's go back. I think I went from red to blue. Nope, didn't mean to do that. Yeah, so the first one was really red, right? 814, 675, and 450. So yeah, let's just do red, green, blue, 1, 2, 3. So colorizing, and I think red is all the way over here, and I want this turned all the way up. So there's our red. Here's going to be our green. And sorry, this is going to go a little bit long. Green is about there. Let me intensify it. And then blue. Come on. Not quite the blue that I want. How about that one? So there we go. It's we need to play with the brightness and contrast. Let's do that. So negative 59 and positive 60. So we'll go negative 60 and positive 60 on all of these. Brightness, contrast. So negative 60. Oh, and positive 60. And then the red one, do the same. And positive 60. Yeah, I don't think that really didn't help much. It's still, sorry, my expertise just went out the window. I definitely need my 10,000 hours on this one. But still, I mean, pretty spectacular view, right? Gotta say. Play with this a little bit more. See, there are misalignments here. Do you see how the red is over here and the green is over here? So, yeah, there's some misalignments that I would have to mess around with. Oh yeah, you see that where I mean, yeah, that's just very very off. So that's at least one of the reasons. Yeah, see, it's a little bit off. So I'd have to correct for all that, and I've taken up a lot of your time already. So yeah, but pretty cool, pretty cool. So that was Capricornus, and what is this thing called? HCG 87. HCG 87. All right, well, cool. I greatly, greatly, greatly appreciate you all coming into this circle of friends, ever growing circle of friends. Yeah, I'll definitely be ordering that camera in the next 36 hours for sure, along with my focuser thing. Um, so that'll be awesome. So thumbs up if you don't mind. Thumbs down, that's okay too. Make some comments. I like to see those. I will respond if appropriate. Um, Make sure to subscribe if you haven't already. Hit the notification bell, and you'll be told when this comes on. But it's every day at 2 hours UTC. 2 hours UTC. So you'll have to figure out what that time is for your location, and consider it a challenge, right? Otherwise, hit the notification bell, and you will be told when I go live. As easy as that. All right. Well, take care, everybody. Thanks for coming along, and I will see you on the spin and the wobble, spinning and wobbling, next time tomorrow. All right. Take care, everybody. Bye.